Hello, everyone. How are you doing today? My name is Guy Royce, and this is Redis Live, Redis Monthly Live specifically. I guess the channel is Redis Live, but the particular program we're watching right now is Redis Monthly Live. We get together every month, and we live stream it, and we talk about Redis. So Redis Monthly Live. The clue is in the name. So today we've got kind of a fun little program here. We've got two wonderful speakers here. We've got Justin Castilla, who, if you've watched the show before, you've certainly seen Justin do the Redis command of the month, or the Redis tidbit of the month, or the show and tell. I'm not sure what we're going to call this. I called it the show and tell, the Redis cube. I'm going to go ahead and bring in Justin here so he can talk as well. But he's going to, he got a little show and tell he's going to do. He's built something kind of cool. And we have Stephen Lorello, who is going to talk about Countmin Sketch to Infinity. And I'm actually particularly excited for Steve's talk because he's going to be talking about probabilistic data structures, which is always a cool topic. But he's going to be doing it from a .NET perspective, which we don't see as often here on Redis Monthly Live. And so Steve is here to fix that. So that's the two people we have on deck today. Welcome, everyone. How you doing?
Good.
I get to our uncomfortable pauses there and lag is me saying it's our way of saying we didn't script any of this.
It's true.
So it's a true story, folks. We just sort of vaguely know what we're doing. So as always, I like to point out that we are Redis, and if you want to try out Redis, you want to try out some of these things that Justin and Steve are going to show today, probably more Steve in this particular case, you can get a free Redis Enterprise Cloud instance at redis.com/tryfree. It's probably the easiest way to get Redis up and running. That is sort of a headless client. You don't have it running on your computer, so you'll need a client to talk to that. And if you need a client to talk to that free Redis Enterprise Cloud, then check out Redis Insight. It's a nice GUI interface to Redis. So these are tools that I use all the time. So I think you should too. So what else we got here? And I think that's pretty much, that's all we got. We can go ahead and hide my little screen here. There you go. So we have a comment from the community already. Hi, community. Hello.
Hey.
Good to see you.
Hello.
So I usually like to do a little sort of banter chit chat with the speakers before we get started. But since we're bastions of professionalism, we haven't prepared any of that. So I don't have any random question about Redis or Redis related topics to ask our speakers today. Do you guys have any good ideas for a random sort of icebreaker question sort of thing? Maybe what's the strangest use case you've ever used Redis for? That might be fun.
I'd like to know more about the lol what command.
Lol what?
Yeah.
That is by far the most essential command of all of Redis.
Very important.
Justin, you should demo that command when you show off what you've built. I think that's
so just so I'm clear, the ASCII art changes with every version of Redis. Is that the case?
Right.
Is it every major version or every minor version it changes too?
I think it's major. I've only seen 2, 5, and 6, so I haven't seen anything change between like 6.02, 6.25, or anything like that. So it takes a lot to make those beautiful works of art.
Do we have any sense as to where they come from? Do they commission a ASCII art painting or something like that? They put it together, or
I think, of course, somebody, keep me honest. I think that it is commissioned by somebody or contributed to, but it's all like some sort of homage to technology. So we have right now with Redis 6 the buildings that were used kind of like in Rampage, that classic game where you're a monster climbing up the buildings, beating stuff up. Which was considered one of the greatest games for its time back in the day. So I think before that was some sort of interesting visual mathematical plot. 5 seems so long ago, so I'm not quite sure.
Yeah. The thing I liked about 5 versus the 6.0 ASCII art is the 6.0 ASCII art is actually not ASCII art, it's ANSI art.
Ooh.
And so when you use Redis Insight to run it, you see all the ANSI escape codes. Yeah. Whereas if you you would do the old lol what with 5.x, you would see you would actually just see the ASCII characters. So,
There you go.
yeah, first world problems of the highest order there, right? So, well, cool. Well, how about we get this started? I think we've bantered enough to give people time to gather around. We've got a few more viewers picked up. So we're going to start this off with Justin. Justin has built something really cool and he wants to share it with us. So Justin, do you want me to share your screen here?
Sure.
I'll add you to the stream. I'll put you in the pole position here. And Stephen and I will go hide.
All right.
The floor is yours, Justin.
Thank you. All right. So as you can see, we've got a little bit of a mashup. Redis, the database on Raspberry Pi, the little tiny computer, equals love. I actually am a fan of the Raspberry Pi micro units. I purchased them ever since they came out with their second model when they're a little bit more affordable. And I just love having at least a couple around to tool with. And yeah, if you don't know what a Raspberry Pi unit is, that's totally fine. Don't worry about it. That's why we're here. I'm going to talk about it a little bit. So let me advance. Boop. All right. So these are the Raspberry Pi units that are new. And they're basically just computers. They have USB ports, they have HDMI ports, they have power ports, everything you'd want on like a laptop. But they're very, very small. And I'll show you an actual physical unit. So right now I'm going to be demoing on the Raspberry Pi 4 unit, 1.5 gig quad core on an ARM Cortex CPU, 8 gigs of RAM. This has surpassed the computer that I used during high school and well into college. Very easily. You can play Doom on this, but you can also play Halo on this at this point. It's really, really impressive specs. It's got gigabit and wireless and Bluetooth, the newest Bluetooth connected on it. So this is a unit that doesn't have to be connected by tons of wires, which is also great for, of course, IoT. That's a major, major component of the Raspberry Pi's attractiveness to a business sense is actually IoT. Also, it's PoE capable, power over Ethernet. So its standard power is 5 volts through just like a standard USB connection. But you can free up a USB connection for other components. That's the normal Raspberry Pi Model 4. Then they have these even smaller ones, Raspberry Pi Zero. 1 gig, same quad core, ARM Cortex, different CPU chipset, but not chipset, different CPU, but just not quite as oomphy because it's not as big. And it has 512 megs of RAM, which is still enough to actually have fun with Redis. And it is wireless and Bluetooth capable. So again, these are smaller units. So why am I here? Why am I talking about the Raspberry Pi as someone who is an advocate for Redis? Well, there's a lot of fun potential for these. You can actually have a Raspberry Pi with Redis installed, and you can just give it to somebody. This is really, really good for development. This is good for onboarding. I would love to give this to somebody who's newly hired at Redis and say, "Hi, explore Redis. Here's a simple, small device that you can connect to." Installing Redis and running it on a Raspberry Pi is very inexpensive. So these Raspberry Pi units, the most up-to-date one, I think, is $35. The Raspberry Pi Zero 2, the little tiny guy, I think is like $25. And so the bar to get in is very, very low and requires very little power. And it's an excellent just addition to whatever you have at your home, like a home network. Also, it's going to be really easy to set up clustering with multiple Pi units. So again, I'm a bit of an aficionado of the Raspberry Pi. So I have four units and one coming in the mail. So I can actually set up my own cluster. And I actually don't have one connected to my network right now, but this is what it looks like. It's in a protective case, but it's just a very small little unit. There is the HDMI, the audio. Oh, thank you. Very nice. And that's the USB power right there. And then there's your Ethernet, and we have 4 USB ports. 4 USB ports. That's actually really impressive. That's better than a MacBook Pro. I said it. I have no regrets. So yeah, These are just really, really fun to learn, and they're really great for students to enjoy. I plan on hopefully going to some boot camps and just sort of sharing these devices inside the class. So actually students can start learning databases early. They can actually connect to something within their local network early. So yeah, that's what's going on. And they're fun. I enjoy actually just tooling around on a little Raspberry Pi unit. So installing Redis on a Raspberry Pi is very, very straightforward. It's just a Linux distribution. You could actually run Ubuntu on a Raspberry Pi if you wanted. The standard operating system they're recommending is a Raspberry Pi OS. And you can just simply go to Redis.io. Here's the link in the bottom. And that's all you really need to get running. There we go. And it's a standard, you pull down the source, you build the source, you make, you install, and as it is, it runs. There is some automation scripts that you can run so it actually starts on power on to your Raspberry Pi unit. And eventually what I would like to do is have a future video down the line where I go through the process of installing that script to actually have it run automatically. Also, I'd love to integrate Redis Insight into the Raspberry Pi unit so you can actually go to the Pi's address on your local network and interact with the keys and inspect all the data structures in there. And again, this runs Redis without any hangups or hitches, so you can run any modules that you want on it. So that's really exciting. All right, so what do I want to do in the future with this? Well, of course, I said I want to make an installation guide for installing Redis on Raspberry Pi. Scripts for automated server restart, and then Redis Insight integration. And let me show you another thing I've built. So you'll see it says here, STL files to build your own Redis Pi. Well, this is what I've been working out when it's been raining up in the Bay Area. I actually have built with my 3D printer my own Redis Berry cube. So this is based off of our logo. I had to do a lot of, I actually printed out the images and figured out the ratios of the little, I don't even know what these are called. We don't have that in our employee manual. But the great thing is I can open it up. And there we go. That's another Raspberry Pi. This is the 0 unit. And all it needs to run is power. So these is 2 different USB cables, one for components, one for power. But once it's all set up, all you have to do is just give it power. It will automatically connect to your wireless network, and it will start serving the Redis server. So literally, you could have just this cube sitting around, powered on, and it's your your development box. And I just think that's a lot of fun. And I'll actually show you a demo of another Redis Raspberry Pi instance. Okay, so this is the actual desktop operating system for the Raspberry Pi. This is for my Raspberry Pi Model 4. And yeah, I already have, I'm not going to go through the whole process of installing Redis. I'm sure that we've all done that plenty of times. But yeah, here we go. I have my Redis server running in the background. I already have the script that's included with the installation source installed. And yeah, Redis CLI, bam. It's just, it works. And greatest thing, it even runs lol what. Whoa. Probably have to, there we go. Cool. And actually, I don't know if anybody with the eagle eye saw that. We can now put in versions. That's really fun. All right, so let's try that. Let's do version 5. Okay, cool. So here's the version 5. So we were right. They were changing things around of every single version. I'm so glad that they added that to Redis. That's a very important feature. So cool. I can actually run it on my Raspberry Pi. As you can see, it's a full-blown operating system. But I can also run it locally. So let me, sorry, I have to do a bit of gymnastics because I'm sharing 2 operating systems and a couple different screens here. Okay, just about there. Thanks for being patient. Okay. Whew. All right. So now here is my work machine. This on the same wireless network as my my Redis machine. As you can see here, I am SSH'd into my Raspberry Pi, and just like normal, I can connect. So this is in the machine again, and contacting Redis, and I have no problems. And then here I am on just a normal terminal. I will connect to my Raspberry Pi instance. And there we go. Okay. So, of course, I have no auth. Shame on me going on here. This is very dangerous. Don't ever do this. Do as I say, not as I do. But yeah, I am connected fully to the server. And the last part, which I really want to show off, and I'll stop bragging. One more time, I will share. Can everybody see my Redis Insight? I hope so. Can't hear anybody because I'm on a different tab. But basically, I can connect to my Raspberry Pi via Redis Insight, which is ultimately what I want to try to do. After all this, showing you terminals, I want to be able to plug in my Raspberry Pi cube, and then immediately go to its, its location and click on my Redis Insight, and I can actually go in and play. Sorry, wrong keyboard. I want to be able to play with my database and actually get it up and running and connect it to a local client for testing or for development. So yeah, that is basically it. One Redis cube to rule all different clients locally, and I think it'd be a lot of fun. If you, of course, want to see any other features physically or software-wise, so if you want to see, I was thinking about adding a little tiny screen to show the address of how to connect to the actual Redis cube, have that displayed dynamically on like an OLED screen on the side of the cube, or actually show how many clients are connected to it, how many keys are in there, just some sort of interesting statistics on the side of the cube. I designed this cube, so I am more than happy to get feedback if we have any 3D printer aficionados or designers out there. This is my first design, and I'm pretty proud of it, but also I'm more than happy to get feedback from everybody. So let's make this a living document. Let's have everybody kind of contribute if you'd like, or ask questions or anything like that, or make a better one. Right now, this one fits the Raspberry Pi Zero, the smaller unit. This one is just kind of glued on with CA glue, but eventually, oh boy, sorry, we'll use the unit that's actually live right now. This is the Raspberry Pi that is currently serving Redis. So I want to actually build a Redis Pi cube that will fit this one, which is a little bit bigger. As you can see, it requires a little bit more cabling. But again, once we make it purely wireless, I don't want to actually connect a lot of peripherals to it. This one's connected to a screen and to a mouse and keyboard. I don't want to do that. I just want to connect it to the wireless and just have it run. So again, let's make this a collaborative living document, and I'd love to get people's feedback. And that is me.
Cool. That is so fun.
Yeah, it's so cool because just sort of the origin story of this. Guy and I were talking, and I don't know if you can see in Guy's background. He's got a printer.
It's hiding under my microphone. Yeah.
And then I've got my big Ender Creality Pro right here, and we're just talking about how much we love printing stuff. And we're like, what if we just print print the Redis logo. Let's stick a Raspberry Pi in it and see what we could do with it. So
Just the 3-dimensional Redis logo is awesome.
thank you. Yeah. It was. I literally printed it out. I took some calipers that I had lying around just to figure out the ratios and stuff like that. So
Yeah. I wonder, like the different squares in the Redis logo, are they actually attached to the same? Is it one cube or not yours, but I mean the actual logo? Are they actually attached to each other, or are they just like 3 floating?
Yeah, I
Where
think
do you
it's
think?
floating. I
Okay.
looked at it a lot. Like I peered into its soul. I didn't see any like connective structuring. So I took some liberties.
When you stare into the Redis stares back. Yeah.
Exactly. In sub-millisecond speeds.
Yeah, in real time. Yeah.
It stares into your soul at microsecond speeds.
I was thinking, you said, what else does this need? It needs blinking lights to show the Bloom filter patterns that Simon's always using, those little matrix LEDs.
Yeah.
It definitely needs some like blinky LEDs, or at least some glowy things going on there,
Yeah, no,
because otherwise how do we know it's technology? Right?
You have like a Countmin Sketch and have like the whole array be like a set of pixels, and they change color and become slightly more intense as the count increases for things.
Yeah, so we can totally do this, and I'm glad you brought up Simon, because he's also a big Raspberry Pi aficionado. So we are definitely going to be working together to produce some really interesting stuff. And the fact that we have different LED matrices that you can connect to a Raspberry Pi very, very easily. So everything that we're talking about is totally possible.
Yeah, Icy Black Deep approves of our idea. Cool. That is a lot of fun. So I'm hoping that we'll be able to make some of these, actually make some proper ones. I think they'd make fantastic swag. Not as in like everybody gets a thing, because obviously there's a bit of a cost here, but this would be a great prize at a conference, or a good speaker gift at Redis Conf, or maybe we could get a bunch of these injected molded, and we pick a random member from the audience from Redis Monthly Live and ship it to you. I think that sounds like a fun idea, doesn't it?
Oh, absolutely, yeah. Unfortunately, it takes about 30 hours total for 1 cube. So I can't have a cottage industry in my room. But
plastics.
Definitely figure something out.
Well, just have to acquire more 3D printers and have like an array of printers running in the background all the time.
There you go. I can probably actually run them all off of a Raspberry Pi server. So
we'll see if Kyle will let us expense these.
Yeah.
Isn't like 3D printing like a big thing in Twitch? Can't you just like stream the printing of these things during for like Twitch streams? I think it's like that'd be very therapeutic. I think.
Yeah, I stared at this thing more than I'd like to admit. Just watching it, I'm like, yes, you're doing it correctly. Just 20 more hours of this, and
does it have like a progress bar in it?
There is. It's a very inaccurate progress bar. So when it's like the inside is hollow, just to save material, and it'll create some geometric structures to make it very sturdy. But when it does all this like zigzagging and geometric suturing together, then the timing goes haywire. It's like it'll go from like 12 hours to 97 hours, and you're like, "What just happened?" Okay, so
you would think that it would like be something that it could definitively say how long it's going to take. It's not like a network download where like your network is being throttled, and it's like
this is the laggiest print ever.
No, sometimes just things go a little awry. I mean, it's the beauty of having an open source 3D printer. Sometimes it decides to print beautifully. Sometimes it decides to like drop the print head straight through the glass, floor of it. So you never really know. That's for another video.
Excellent. Well, we should probably move on to the next talk. Justin, you have made a very cool thing. We need to turn it into injection molding and get more of them made. So, so get on it. Excellent. Well, thank you very much, Justin. Up next, we've got Stephen. Steve has let me just share your screen here. There we go. Put you in the pole position. And Steve has I don't know why I want to call you Steve, and I know you go by Steve, but it's become ingrained. Apologies.
It's fine. My like I said, my wife and my mother call me Steven. It's okay.
Yeah, I need to get your middle name down, then I can address you like your mother.
Actually, I don't think my mother ever used my middle name. My aunts did, though, when they would yell at me.
So Steve has a wonderful talk on Countmin Sketch to infinity using probabilistic data structures to solve all sorts of cool problems using .NET. And so, Steve, the floor is yours.
Sounds good. Yeah, sorry. I know the title's a bit of a mouthful, but I really do think it's a really neat topic. The crux of this talk is going to be diving into probabilistic data structures and using them to solve all sorts of neat problems using both Redis and .NET. And so for some background, like I said, I'm Steve Lorello. I am the .NET developer advocate here at Redis. So before I give any talk, I usually like to go over a little bit of an agenda of what I'm going to be talking about. The first thing we're going to be doing is answering a question. What are probabilistic data structures? And then we're going to be looking at set membership problems and using Bloom filters to solve those. We're going to be looking at counting problems and using a Countmin Sketch to solve some of these counting problems. And then we're going to be looking at cardinality and distinct count problems and using HyperLog Log to solve those. And then we're going to be looking at some examples of using these data structures with Redis. And specifically, I wrote a little .NET app to show folks sort of how they can be plugged into your application. So first, let's answer the question. What is a probabilistic data structure? A probabilistic data structure is a class of specialized data structures that tackle very specific problems. And instead of using, and the key feature of all of them is instead of using brute force to solve the problems exactly, they use some clever accounting tricks and some probability to approximate answers. So some examples of probabilistic data structures, they solve all sorts of problems. Bloom filters, quotient filters, Cuckoo filters, essentially solve presence problems, set membership. Skip lists solve ordering and searching problems. HyperLog Log solve cardinality problems. Top Ks, there's Top Ks is a bunch of Top K algorithms, and the Countmin Sketch solves counting problems. And a bunch of these are actually available in Redis, and they all have similar optimizations. Usually they'll optimize space. Oftentimes you'll be optimizing something like insertion times and skip times. So like in skip lists, they essentially allow you to maintain ordered searching, but as opposed to like some other list structures, they actually have optimal insertion and search times. So anyway, let's move into our first type of problem, and that's set membership. Set membership is basically asking the question, has the element in question been inserted yet? So for example, you might have a system that requires a unique username and email for before you're registering for the service, any sort of account. Now, a naive approach to solving a presence problem would be to store all the user information in a table for users and then querying that table. It's pretty simple. And if you're working with a small set of data, this is really definitely a pretty decent way to go. And you solve this, you would insert the username, the users, and then you would just do a select one from users where that username equals username. And if it's present, then you say, oh, well, I know that this is present. Now, if you're doing this in a traditional SQL database, like the access type is either disk or it can be in memory too, assuming the table's been loaded in memory. But your worst case access type is disk, which is slow. The lookup time is order n because you have to scan through the whole table. And but the nice thing is the extra space beyond storing the user information that you need to store is order one. You don't have to store anything else. You just store the user information you're looking up. So that's naive approach one. Naive approach two might be to store the user info in the table for users again, but instead of just storing it, you would then index the username. Indexing the username would essentially store all your usernames in a B tree, which would allow you to more quickly access it. So you would use that same query to look up the username again. And nothing has changed from the last time, except instead of an order n operation to look things up, it's order log n, which is quite nice. But the trade-off is that the extra space that you need to store this index is order n. So you need to expand your the size of the memory that you're using or the disk space that you're using by order n in order to accommodate the index. Another naive approach might be to use something like Redis. You would use Redis as a cache to store the usernames and then quickly access them. So you would store the usernames in a Redis cache, and to store them, you would use a set, and you would add the username to the set. And then when you're looking it up, you would then check that set to see if that username is in there. And this is really nice because it's now order one lookup time, and the access type is not disk anymore, it's memory, which is a lot quicker and, well, guaranteed to be quicker. Like I said, a table can be loaded in memory as well. But you're guaranteed to be in memory. Lookup time is now order one. And the extra space you need beyond storing the user info is now order n, because you still have to store all the usernames in memory. And that's where Bloom filters come in. So Bloom filters are a specialized probabilistic data structure for running presence checks. And so the trick to them is that they can say definitively if a member has not been added yet to the Bloom filter. And it can say probably if an element has been added. Now they use this k-hashes scheme where it runs the record through a series of hashes to essentially set a bunch of bits in an array, in a 1D array. And using that, it can essentially tell you with a decent probability whether the element has been added or definitively if it hasn't. And we're going to walk through in a second to see this in action. Now, all the operations in here are order one complexity. They are constant in the number of hashes that you have to run. But the space complexity now, while still order n, is now order n but in bits instead of the actual size of the data that you're storing in the structure. So it really crushes and compresses the data that you need to store. So an insertion for a Bloom filter looks like this. You go through all of the k-hashes, and then you index into the filter for that hash to that key. So like if you're storing a username in here, you hash the username's key with each hash, you index into the filter, and you set that to 1. A query looks sort of like the opposite for this. You just go through all of the hashes, you check to see if the filter at each hash is set to 0. If it's 0, you return false, and if they're all 1, you return true. So the complexity for this, like I said earlier, is still order n bits, order n, but it's in bits instead of the size of the actual structure that you're inserting. Insert time is order 1, lookup is order 1, and deletes aren't, you can't really back things out of a Bloom filter without breaking it down. So let's look at an example. So say we are using, we're using our username example, and we're going to initialize a very simple Bloom filter with a k equal to 3. So it's going to use 3 hashes, and it's just going to have 10 bits in it. So say we want to insert the username Razzle to this. So h1 of Razzle, so the first hash function of Razzle, is equal to 2. So we go to the slot 2 in our Bloom filter and set that to 1. h2 of Razzle is equal to 5. So we go into slot 5 of our Bloom filter and set it to 1. Likewise, h3 of Razzle is 8. So we go to slot 8 and we set that to 1. Now, if we wanted to now query another username, say Fizzle, well, h1 of Fizzle comes out to 8. Now, bit 8 in here is set. So we can say maybe Fizzle is in the Bloom filter. h3 comes out to 2, which is also set. So still, maybe we can't say definitively whether Fizzle has been inserted into the Bloom filter or not. And h2 of Fizzle comes out to 4. Now, bit 4 is not set. So we can tell you definitively, no, Fizzle has not been added to this Bloom filter. So this actually brings us to an interesting problem. If all of these bits have been set, any attempt to insert or check anything in this filter is going to result in a false positive. And that actually comes to something that's really important with Bloom filter is understanding how false positives work and how to optimize them. So this algorithm, like I said, is never going to give you a false negative, but it can possibly report false positives. And you can optimize false positives by optimizing K. You can optimize K and also the actual hash table size relatively easily. Optimal hash table size, you have to know something of the order of the cardinality of the set that you're working with, like approximately how many records do you think are going to be inserted into it. And from there, you usually say like, I think like 8-ish bits per record. So essentially a byte per record that you are expecting to insert into this. And then we can optimize K by taking that size divided by the number of records. So that would be to get this constant C. So like I said, this is about 8. And you can optimize K by multiplying that constant by the ln of 2, the natural logarithm of 2. And this will result in a false positivity rate of 0.6185 to the C, which is going to be quite small. And don't ask me how that's calculated because I have completely forgotten how to calculate this. But it's in one of the proofs of the paper that initially introduced the Bloom filter. So that brings us on to our next problem. That's counting problems. So what are counting problems? In this case, I mean, there's all sorts of combinatorial counting problems, but in this case, we're referring to how many times does an individual set number occur in a stream. So this is easy to do for small size streams of data. But an example where this could be really hard is counting views on a web service of a video on a web service like YouTube. So this is nearly impossible to do at scale well with enormous data sets. So a naive approach to handling this might be to use like a hash table. You have a hash table of counters and you look up the name on the hash table, the actual key in the hash table, and instead of storing the record there, you store just an integer. And on insert, you increment that integer, and when you query it, you can check the integer. So the pros of this is that it's really straightforward and you have guaranteed accuracy. The con of it is that your space complexity is order n in the best case. And in the worst case, it's order n time complexity. And it scales really quite poorly. Think having billions of unique records. And if you're relying on only a single hash, you're very vulnerable to collisions and overcounts. So another naive approach might be to use a relational database. So you would issue a query to a traditional relational database searching for a count of the records where some condition occurs. So say you want to count the number of views for Gangnam Style. This is not a great operation because you have to scan through the whole table in order to count all of them. So you have to pull the whole table in, scan through all of it, and count them all. And if you have, billions of views of something, you have to scan over all of them and count them all. So this is a very complex operation. It takes a long time, and you have to store all of the views also in the database. It can't be transient. So it's a linear space complexity, linear time complexity. So it could take a while. It's not great for large data sets. So what's the problem here? Each unique record would need its own spatial hash table or row at RDBMS, and it's really taxing on memory for hash tables and maintaining large data structures like this. In a typical program's memory isn't necessarily feasible, and in a relational database, it's all stored on disk, so it can be pretty slow. So that brings us to the Countmin Sketch. The Countmin Sketch is another one of these specialized data structures for keeping count on very large streams of data. They're very similar to Bloom filters. They use a multi-hash record keeping system. But instead of maintaining a 1D array of bits, now we're maintaining a 2D array of counters. And it's sublinear in space complexity. I would almost say it's effectively constant in space complexity, and it's constant in time complexity. And it never undercounts, but it can sometimes overcount. So an increment operation in a Countmin Sketch looks like this. Very similar to how the Bloom filter worked, but instead of setting the record to 1, you just increment it by 1. And the query in a Countmin Sketch is similar-ish, I guess, but you go into each table record. So you look at each counter that's indexed by the hash, and you take the minimum over all of those records. And you just return the minimum. That's why it's called the Countmin Sketch, because you're counting the minimum counter and returning that as the response. So let's take a look at a video view sketch, for example. We're going to say this is 10 by 3. So 10 counters per hash and 3 hashes. Say we want to increment Gangnam Style. We would say we run Gangnam Style through H1, it comes out to 0. So we increment H1 0 to 1. H2 of Gangnam Style comes out to 4, so we increment H2 of 4 to 1. H3 of Gangnam Style comes out to 6, so we increment H3 6 to 1. Now, if we want to increment Baby Shark, Baby Shark's H1 comes out to 0, H2 comes out to 5, H3 comes out to 6. And you'll notice that those are 1, 0, and 1 right now. So we just go to H1 of Baby Shark, which is 0, and we increment that to 2. H2 of Baby Shark is 5, so we increment that to 1. And H3 of Baby Shark is another collision, 6, so we increment that to 2. And now when we come back into query Gangnam Style, we look at H1 of Gangnam Style, which is 0, and we see that's 2. So maybe Gangnam Style is 2. H2 of Gangnam Style, though, is 4, and the record stored there is 1. So we know that it's at most 1. H3 of Gangnam Style comes back 2. So we take the minimum over all of these, and we get the result, which is 1. So the complexities of this is that in space, it's sublinear. To increment or query, it's order 1, and deletions are still not available. So the pros of a CMS is that it's extremely fast and it's very compact, and it's impossible to undercount. The cons of a CMS, though, are the incidence of overcounting, and all the results in the sketch are approximations and aren't necessarily accurate. And I would say that if you are, working on like a banking application or something like that, where you need to maintain balances across accounts, maybe not the best thing to use, unless, of course, you're working with my account, in which case you can overcount the money in my bank account all you want. So when should you use a Countmin Sketch? When you're counting many unique instances, when approximation is fine, and when counts are likely to be skewed. So say, like, again, going back to our YouTube example, you have millions of videos. Some videos on YouTube have billions of views, others have no views. So that's a great use case for them. And that brings us to the last problem that we're going to be looking at, which is set cardinality. So set cardinality are counting all of the distinct elements that have been inserted into a set. It's easier on smaller data sets. And for exact counts, you must preserve all of the unique elements. And this also scales really poorly when you're working with very large data structures or very large data sets. And so this is just going to bring us right into the HyperLog Log, which is the last of the data structures we're going to be looking at. The HyperLog Log is a probabilistic data structure to count distinct elements. Its space complexity is order 1. It is extremely compact. Its time complexity is also order 1. And it can literally handle billions of elements in less than 2 kilobytes of memory. And it can scale up as needed. Like I say here, it's effectively constant, even though if you're working with enormous cardinalities, you may increase the size just a little bit of your HyperLog log. So this is also the quirkiest of the data structures we're looking at today. To initialize a HyperLog log, you just initialize an array of registers that's size 2 to the p. And this p constant is a value that you set in the beginning. It's usually like 16 to 18. I think the one that Redis uses is 16. When an item is inserted into the HyperLog log, you determine the register to update with it in it by hashing the item and then taking the left p bits of the item's hash. And so you set that register, whatever that index is, to the rightmost one in the binary representation of the hash. And how does this work? It's really quirky, but like the probabilities here, as you start working over from the rightmost bit, the probability that a given bit is going to be the first one goes way down as it goes across. It actually decreases exponentially. So like, what's the probability that your rightmost bit is 1? Well, it's either even or odd number, right? So it's 1/2. When you move over 1, it's now 1/4, 1 to the 16th, 1 to the 32nd, 1 over 32nd. And it just goes down tremendously in probability as you go across. And it uses all these registers to combine together using a harmonic mean to determine what the actual cardinality of the set is. It's a really quirky algorithm. I'm going to do a quick walkthrough of it before we move on. So let's say we wanted to insert the username bar into a HyperLog log that has p set to the 16. So the hash of bar comes out to this large number, which is like 3.1 billion. And then we take this binary representation of this, and the first 16 bits in here, so these, come out to 47,357, which is our register index. And the index of the rightmost one in here is 1. So we set the registers at that index to 1. And then when we query it, we calculate the harmonic mean of only the set registers. So the only set register in here is 47,357, which is 1. So we multiply, this is really quirky, but we square the cardinality of, or the number of set registers by a constant 0.673 and divide that by the harmonic mean of all of the set registers. So 2 to the each register. It's a really quirky algorithm, but it actually does get the right answer with the cardinality of 1. So that brings us to using all of these data structures with Redis Bloom. And the first 2 data structures we looked at, Bloom filters and Countmin sketches, are available in Redis Bloom, and the HyperLog log is just available in any flavor of Redis you might want to use. But Redis Bloom is a module for Redis. It's essentially a plugin for Redis. It adds functionality for Countmin sketches, Bloom filters, top Ks, Cocoa filters, all to Redis. It's available under Redis source available license. So you can either use it through like its Docker image. You can compile it from source, as long as you're not using it to build a SaaS application that provides Bloom filters or Bloom filters or any of these as a particular solution, and is also available in Redis Enterprise. So with that, I'm going to actually pop into some code here, and I guess the first thing to do is probably to start up Redis with this. So you want to start up Redis with a Bloom filter. You can do docker run-p 6379:6379, and it's Redis lab/ru. This is going to spin up now. And before I do anything else, I'm going to just seed Redis real quick with the data that I'm going to use for this. Where's this? want to say it's, yeah. I just added some YouTube videos to Redis to actually start with. But yeah, so if I run this little application that I wrote right now, and I pop it open, I have this little Blazor app where I can create an account. It does not like my username, my email, blah is my password. And then it just goes to YouTube and it pulls down a bunch of videos, like popular YouTube videos. You can play them. So you can just look at them. But you'll see that right now, the total views, unique views are both 0 for this, even though I'm looking at it. And if I try to go back out, I log out, and I try to create foo@bar.com again with the username blah, which are both already inserted, that it's allowing me to insert them, which isn't quite right. We would expect it to not allow that. So let's start off. I guess we'll start out by looking at the username and password stuff. So to solve this, to make sure that a username and password are unique, the first thing I'm going to do is actually take a look at where I create the usernames and passwords. So in here, it's just accepting just this little razor page, and you take the sign up form, which is just an email, username, and password, and it just inserts it. It decrypts the password so that it's not, stored in the clear or anything. But that's about it. And when this is done, so when this is actually set in Redis, so it actually does a hash set for users in here. When it's done, we need to run a Bloom filter add to this. So we're going to create a couple more tasks. T2 equals db.execute async. And we're going to run bf.add, and we're going to use this username filter, and we're going to insert the username. And then we're going to do the same thing for the email. bf.add username, or not username filter, email filter, form.email. And at the end here, we're just going to await these two tasks so that they all sort of get pipelined to Redis and run at the same time. And that will add the username and email to a Bloom filter for us. So it adds the username to the username filter and the email to the email filter. And then the next thing we need to do is when we're actually validating the form on this page, I have a little form validation, custom form validation going on here. And I have rules for here. And with each of these, I want to make sure that, this doesn't exist in Redis yet, right? So I will just say db.execute async bf.exists. So bf stands for Bloom filter. .exists. Does it exist? And this is the email one. So I will say email filter and email. And I'm going to return whether this cast of integer is equal to 1. So when you run bf.exists, it'll return a 1 to you if it exists and a 0 if it doesn't. I do the same thing here, but with username instead. It wants me to just make this a straight lambda function, but I'm not going to do that because that would just make it a little more stretched out. So at this point now, I can actually close this and run it again. I can pop into Chrome again, and you'll see that foo at bar. Oh, no, this is actually wrong. I'm sorry. This has to not equal 1. Not equals 1. Oops. Yeah, so I'm validating that the account, the name doesn't exist. So yeah, some little backward logic here. Oops. So foo at bar.com. Blah. Now you'll see that I'm actually creating the same account again, but that's just because foo at bar.com hasn't been added yet, and blah hasn't been added as a username. So if I go back into here and I try to add foo at bar.com again, you'll see that it's now validating it and saying, oh, that's in use already, so you can't use it. If I try to create bar at foo.com, and bar is my username, I can submit that, and it'll create it for me. So that brings us to our next thing, which are the total views. So for the total views, we're going to use a Countmin Sketch. Now the Countmin Sketch is actually initialized a little earlier using just this little script here. And I'm initializing it just with an init by dim. You can use init by there's like an init by probability too, where you just feed it some parameters and it creates something for you. I like to use an init by dim personally, just so I can keep a little bit more control over it. But essentially, this has 500 counters for 5 hashes. So in my code now, I'm going to go to my to-dos, and in here, this is where the actual video is clicked into, and you start playing it. And here I'm going to run an anchor by on the CMS. So I will do db.execute async cms.anchorby, and I will pass in the name of the sketch I want to use, which is going to be total view sketch, and I will pass in the ID of the item I want to increment, and I'll finally pass in the amount that I want to increment by, which is 1. So cms.increment by the sketch that I want to increment, the ID of the video that I want to increment, and 1. And if I go into the video service, which this is just a little service that's being used to populate the videos and populate the metadata for the videos. This is what I'm getting the video data for a bunch of videos. This one where I'm just getting the data for a single video. But if I go into here and I set total views to db.execute, and I can pass in cms.3 total view sketch and the ID. You cast that to an integer. That will populate the views on the main web form, and I'll do the same thing here. And when I go in to run this now, this will actually get the total number of views that you've clicked on it. So if I go to Despacito, all right, it says 1, now it says 2, and 3, and so on and so forth. It'll just keep incrementing however many times someone clicks into the video. So we'll just pop out of this now. But you'll notice that the unique views is not moving at all. That's because we haven't added the wiring for the HyperLog Log yet. And now, like I said, the HyperLog Log can be used without Redis Bloom. But to get the unique views, when we hop into the video, I'm going to get the user from the authentication state, specifically the claims of the user. And I will then do a db.execute sync. Oh wait, no, I actually don't need to use execute sync because it's just HyperLogLog add. And the name of this HyperLogLog is going to be HL:E. So you're going to have a unique HyperLogLog for each video, and I will pass in the username. Sync. I'll need that. And then in here, I want to set the unique views to db.hyperloglog length, and that's going to be HL:ID. And I need to probably cast this to an int. And pop that in there too. Now when I go back to run here, and I log in, see, it just really doesn't like my blah password. It just says that's a compromised password. It's dangerous. I guess you want to use foo@bar.com with blah as password. But when I pop into here now, and I click in here, the unique views will then increment. And even though I keep clicking into it, the total views keep incrementing, the unique views stay the same because, well, I've only checked it once as this username. But if I go into r@food.com, log back in here, and into this one, oh, look at that. It's not unique anymore. That's not a unique username anymore, so it increments it. So yeah. But that's it. A little bit more about me before I go. I am Steve. Again, I'm a developer advocate here at Redis. You can follow me on Twitter, on GitHub, or you can follow my blog at redis.com. Some resources. Obviously, Redis.io is a great resource for anything Redis related. Redis Bloom, the documentation for that is at redisbloom.io or oss.redis.com/Redis Bloom. The source code for this document for this demo is in GitHub. And I also wrote some C# implementations for the Bloom filter, HyperLogLog, and Countmin Sketch for the algorithms project. So yeah, come check us out at Redis University or on Discord. And does anybody have any questions? So I guess I'll pop back out here.
Yeah, we're at that awkward time where we have to wait on lag. Yes, several apparently. Yeah.
So, I love this. I'm sorry, I just love that GIF.
It's a fantastic GIF.
David S. Pumpkins is one of my favorite SNL characters of all time. I guess I'll stop it now.
Yeah. So, well, thank you very much.
Yeah.
For whatever it is you just did now, for giving a talk, for the talk you just gave, Steve. It's much appreciated. I know I don't have any questions. I did find the bit on the math inside of HyperLogLog interesting because I haven't looked at that before, and I can't say that I honestly intuit how it works now any more than I did before.
But it's like super quirky.
Yeah. And so I feel like that's a little challenge I need to give myself is to implement a HyperLogLog and get my head around how it really works. Maybe I'll make a highly efficient one in JavaScript. So again, thanks. And yeah, I'm not seeing any questions, which is fine. So yeah, I think that's all we've got. Do you have anything else you want to wrap up with before we shut this down, Steve?
No, that's it for me.
What about you, Justin?
No, thank you everybody for listening. And if you ever want to ask any questions, yeah, definitely hit us up on Discord. I'm more than happy to answer any questions.
Yeah, cool. Well, I suppose we should say what we have happening next month. So next month, we've got a whole mess of us So there's Andrew, Steve, myself, and a very young-looking Brian Sam Bowden.
Absolutely cherubic.
Yes, absolutely. That's not a word we get to use. You're really bringing out the lexicon today, aren't you?
Thank you.
And we've been working on something really cool. We're going to announce it next month. I can't say what it is, but we've all been working on it. So come and check that out next month. That's what we have on deck. And then in January, I think I've got someone lined up for January, a friend of mine by the name of Nilanjan. So hopefully he'll be in January, but it might be February. We haven't got it figured out yet. But that's what we've got coming up next month. And of course, if you don't want to miss the big thing next month, the greatest way to make sure that you're warned when we're ready to go live is to join Redis Live at meetups.redis.com/RedisLive. You can subscribe to our YouTube channel, and when we go live, you'll see that there as well. And of course, give us a follow on Twitch, which hopefully you're doing right now. So that's a great way to know when Redis Monthly Live goes live. And a lot of the other content we've been streaming as well has been going on Twitch lately. Justin's been doing a lot of that with Suze. So lots of good stuff out there. Lots of stuff to check out. And I saw a question come through over on Twitch, but StreamYard hasn't found it yet. So I'm going to sally forth here. Here it is. It wasn't a question, it's a comment.
Oh,
you're very welcome. I'm not sure which part of your name to say first, Calix Enrique Ortega Rodriguez, but I'm just going to say it all. So yeah, give us a follow on whatever platform you prefer, and go ahead and connect with us. We have a Discord server at discord.gg/Redis. So all of us are hanging out there all the time. So if you've got questions, you just got ideas for shows, you just want to talk to us, we're there, happy to help. And give us a follow on Twitter as well. So, and oh yeah, most importantly, I'm always looking for speakers. So if you are interested in speaking on Redis Monthly Live, go ahead and reach out to me. You can email me at guy.royce@redis.com. I know that's a shockingly surprising email that it would be guy.royce@redis.com, but that is indeed my email address. So send me an email out there, or hit me up on Twitter, or you can honestly, if you type Guy Royce into Google, you'll just find me. So I'm easy to find. Reach out to me. Let me know if you're interested in speaking. If you know someone that you think should speak, if you'd like to have them speak and want me to reach out to them, let me know that as well. I'll be happy to reach out to them and schedule them for a talk. So I think that's the last slide. Yep, that's what we got. So thanks a lot, everyone. And I'll see y'all later. You guys want to say bye? Any final farewells? Do you have any last words?
Have a wonderful, fantastic work week. We'll be thinking of you.
Yes.
And for those of you in the United States, have a happy Thanksgiving here real soon. So we won't see you until before Christmas. So thanks, everyone.
Right.
Bye.
See you later.
Bye.